Good morning, dear children. Welcome back. In the last class, we discussed about a few topics on gravitation. We talked about the equations of freely falling objects. We talked about equations of freely falling objects. What are the three equations we discussed? The first one was V is equal to U plus GT. The second was H is equal to ut plus half gt square, and the third one we discussed was v square minus u square is equal to 2gh. So let us continue with the same. We talked about other conditions also, like if a body is thrown up, g is taken as negative. If a body is coming downwards, g is taken as positive. Then we also talked about when to take g is equal to plus 9.8 meter per second square and when to take g is equal to 9.8 meter per second square. We also solved a few numericals related to these equations. We will be also doing the exercise questions later on, but let us discuss a new topic today, that is mass and weight. So our topic of discussion would be mass and weight. You are familiar with these two words, but the most common mistake that everyone make is someone asks you what is your weight, you say 20 kg. Someone asks you what is mass, you feel difficult to answer to that question. So we will be discussing what is the difference between this mass and weight today. Now what is mass? Mass, it is the quantity of matter present in a body. The quantity of matter present in a body is called as its mass. So the amount of material that is present in the body is mass. Okay, so mass, it is represented as m, represented as by small m. The small m is the mass of the body, and what is the SI unit? SI unit is kilogram. SI unit of mass is kilogram, and we write it as kg. Now if you look at this definition, the quantity of matter present in a body is called as its mass. Because it is the quantity of matter, it is never going to change. It is going to remain same everywhere. So mass of a body never changes, it is always fixed. Mass of a body is a fixed quantity. It never changes. It never changes. Now if you talk about chemistry, you have talked about what is matter. What is matter? Anything which occupies space and has got mass. So if you talk about any matter, it has got some mass. So the next condition is, if the question is can mass be zero, mass of a body can never be zero. So the next point we can write is mass of a body can never be zero. So mass is not equal to zero. Mass is a finite quantity, it has got some value. So mass is never equal to zero. And about quantity of matter doesn't have any direction, it has got a magnitude. 1 kg, 2 kg, 3 kg, 4 kg, that is a magnitude. So it doesn't have any direction, therefore mass is a scalar quantity. Mass is a scalar quantity. Mass of a body can never be zero. So these are the points you have to remember. If the question asked is write a few points on mass, you have to write these points. Now there is another point also which we can write here. Mass is not affected by the presence of other objects. So if we have, let us say body A, let us say this is body A having mass m1 and body B having mass m2, the mass of the body A remains unaffected by the mass of body B. The masses would remain always same. So you can write here mass of a body does not get affected by the presence or absence of another object, another body. Like if you talk about your body itself, anywhere you go, the mass of the body would remain same. If you are 50 kg in Hisar, you will be 50 kg in Delhi, you will be 50 kg in Rajasthan, wherever you go. If you go to America also, the mass would remain same. Mass would never change. If you could increase or decrease the quantity of matter, naturally the mass would change. And if you are not increasing or decreasing the mass, the quantity of matter, the mass of the body would always remain same. Okay, so this is all about mass. Mass can never be zero. You just have to remember this thing. Mass is never equal to zero. Mass has got some value. Now let us talk about weight. So the next heading would be, or next topic would be weight. Now weight, let us try to define it first, then we will try to understand what it means. The force with which a body is attracted towards the center of the earth. We are talking about earth. We may, if we are on the moon, we would say the force with which the body is getting attracted towards the center of moon. If we are in Jupiter, then we would say the force with which the body is getting attracted towards the center of Jupiter or Mars or any other planet. So it depends on the planet where you are. Now if we are on the surface of earth, we would say the force with which a body is getting attracted towards the center of the earth. So if we take, or let us imagine a spherical object which is the earth. Let us draw the earth here. So if this is the earth, this is the center of the earth. and a body is here. Now this earth has got a capital M mass. M is the mass of earth, capital M. M is the mass of earth and small m is the mass of object. And let us say this distance is r. Let us say this distance is r. So what would be the force of attraction if we remember Newton's law of gravitation? So force of attraction between the two objects, two bodies. What are the two bodies here? Earth and object. So if we use Newton's law of gravitation here, F would be equal to capital G, mass of earth is capital M, mass of object is small m, divided by r square. This is what we get. Now this can be rewritten as m g m upon capital R whole square. Now in the last class we discussed what is gm by r square. Capital G capital M by r square can be written as small g. So we get this equation would now change into F is equal to small m into small g. And what is this force? Just now we have defined the force of attraction, the force with which a body is attracted towards the center of earth is called as the weight. So instead of F we can write, therefore weight of the object is equal to W, and this is same as the force, and this is equal to m into small g. So this is definition of weight. So W is equal to mg. We get this equation. So weight, now if your mass is 50 kg, let us say for example, if your mass is let us say 50 kg, and we know g is equal to 10 meter per second square for earth. So what would be your weight? Weight on earth, weight on earth would be equal to mg, and this is nothing but 50 into 10, and this is nothing but 500. Now force, we are calculating the force of attraction, so the unit is Newton. So what is the SI unit of weight? SI unit of weight is Newton. So you have to remember this point also. Weight is equal to mg, and second thing is weight has got the unit, the same unit as that of force. So force is mg, force is equal to ma. In second chapter you must have read Newton's law of motion. The second law says force is equal to mass into acceleration. Just here in place of a we are writing g. Now the third important thing, if you see the formula or the definition, it says the force of attraction between the body and the center of earth. It is the force of attraction, and we know that force is a vector quantity. So what about weight? Weight is a vector quantity. Weight is a vector quantity. It has got it has both magnitude as well as direction. Okay, so this is the next point to remember. Weight is a vector quantity. Now we just discussed W is equal to mg, and we discussed while acceleration, when we were talking about acceleration due to gravity, which said when can g be 0? Small g can be 0, small g can be positive, small g can be negative. Now when is g is equal to 0? G is equal to 0 at the center of earth, or if you go to the outer space where acceleration of gravity can be neglected, g is equal to 0. So weight is equal to 0. Weight is equal to m into g is equal to 0 when g is equal to 0, because mass can never be equal to 0. So mass is never 0, g can be 0. So if g is equal to 0, weight of the body can be 0. Okay, now we have discussed that mass can be 0, but mass can never be 0. But weight of the body can be 0. It can be positive, it can be negative. Negative कब होगा? Negative तब होगा जब g हम negative लेंगे. If the body is moving up, the weight would be negative. Negative means it is actually the direction of the body is opposite to the force of gravity. Okay, so g is equal to 0, so weight would also be equal to 0. Okay, we have talked about vector quantity also. Let us talk about two more units. One, this is the unit of weight, but if we talk about gravitational unit of weight, it is, there is another unit called gravitational unit of weight. What is the gravitational unit of weight? It is kg weight. So how to define this kg weight? We will define this as the force of attraction, between a body of mass 1 kg and the earth. If you take 1 kg mass, then weight is equal to m into g. So this would be 1 kg into 9.8 meter per second square. So this is 9.8 Newton. So mathematically 1 kg weight, this is the second unit of weight that we were talking about. 1 kg weight is equal to 9.8 Newton. This also in some questions it is given a body has got a weight of 5 kg weight. 5 kg weight का मतलब क्या होगा? 5 kg weight का मतलब क्या होगा? 5 kg weight means 5 into 9.8, so it is 49 Newton. So you can change kg weight into Newton just by multiplying 9.8. Okay, so this is about weight of the body, and when g is equal to 0, then weight of the body would be equal to 0. Now another very important thing, a common thing which you have to remember, weight of a body is measured using a spring balance. You must have seen a spring balance in your labs. we will use a spring balance to measure the weight of the body. Okay. Now if you are having a mass of, let us say, 50 kg, or let us say 100 kg or 70 kg, let us do a small question. A person has a mass of 40 kg. What would be his weight? What would be his mass and weight on the surface of moon? On the surface of moon. If you remember last time when we were talking about acceleration due to gravity, I had told you that acceleration due to gravity on moon is nearly 1/6 of the value on earth. So if we take the acceleration due to gravity on earth to be 10 meter per second square, then on the surface of moon, on moon it would be how much? It would be uh, uh, 10 upon 6 meter per second square. We will establish the relation after some time. So now look at this question. The mass of the body is 40 kg. This is fixed. Now this doesn't change. Now this mass wherever you go would remain same. Weight depends on g. Weight depends on small g. So if the value of small g changes, the weight of the body would change. Mass is a fixed quantity. So if you go to moon, or if you go to the surface of sun or Jupiter or any other heavenly object, wherever you wish to, the mass would remain same. So the answer would be, as mass always remains constant, always remains constant, therefore mass of the person on moon would be same as how much? 40 kilogram. Now the question comes, what about his weight of the body? Now weight, I have already told you, weight depends on the acceleration due to gravity. And what is the acceleration due to gravity on moon? On moon g is equal to 1 by 6 times g moon is equal to 1 by 6 times g earth. So this would be equal to 10 upon 6 meter per second square. If we take the value of g to be 10 meter per second square on earth, it is 10 upon 6 meter per second square. So what would be the weight of the object or weight of the person on moon? Therefore weight of person on moon is equal to mg, and this is nothing but m is 40 kg into 10 upon 6. So if you solve this, how much do we get? This is 40 into 1.63, so 16.3 into 4. So it is 65.2 Newton. This is the value on moon. What would be his weight on earth? On earth it would be 10 into 40. So on earth, weight of the person on earth is equal to mg. So this is 40 kilogram into g is 10 meter per second square if we take 10. So this is nothing but 400 Newton. Now see the value. So when you go to the surface of moon, the weight of the body decreases by 1/6 times. तो जो आप अगर मून में जाएंगे तो आपका वेट जो है 1/6 फील होगा. So you must have seen the videos of Neil Armstrong or the astronauts walking on the surface of moon. वो चलते भी है तो वो काफ़ी ऊपर तक जंप करते हैं, तो एक्चुअली वो थोड़ा सा उनको वेट कम होता था. वेट द पर्सन फील्स लेस वेट on the surface of moon. Okay, now if you see the value of the weight of the body on moon is becoming 1/6 times. So let us establish this relationship. So write down, I think you must have understood what we have talked till now. The last topic for today, let us see. Let us take the values. We would take, if the mass of earth, if the mass of earth is 100 times that of the moon, and radius of earth is 4 times that of moon, then prove that a body weighs 1/6 times on the moon as compared to the weight of the object, weight of the body on earth. So this is what we have to prove. This is the question given, that the mass of the earth is nearly 100 times that of the moon. Now, this is the known fact. So mass of earth is 100 times that of the moon, and the radius of earth is 4 times that of the moon. So if we take mass of moon as m, if mass of moon is equal to m, then what would be the mass of earth? This would be equal to 100 times m. Similarly, if we take radius of moon as r, then we would get radius of earth is equal to 4 times r. So if we calculate the value of small g on moon and on the earth, then whatever value we get, we can multiply it with the mass of the body to get the weight of the body. So from these informations, let us find out g moon and g earth. G moon is equal to capital G into mass of moon divided by radius of moon whole square. So this is G moon is equal to G m by r square. Let us say this is equation number 1. In the same way, if we find out the value of G earth from these values, so we will get G earth is equal to capital G into mass of earth divided by radius of earth whole square. Now let us put the values. So G Earth is equal to G, and what is the mass of Earth? Mass of Earth is 100 times mass of Moon, and radius of Earth is 4 times radius of Moon whole square. So we get G Earth is equal to 100 by 16 into Gm upon R square. Okay. Now what is this Gm by R square? Gm by R square is nothing but G Moon. So therefore we get G Earth is equal to 100 by 16 into G Moon. So put the values now. If you put the values, or if you transpose G Moon to one side, G Moon is equal to 16 upon 100 into G Earth, and 16 upon 100 is roughly equal to 1/6. So we get G Moon is equal to 1 by 6 into G Earth. If the acceleration due to gravity on Moon is 1/6 that of the Earth, what is the conclusion then? Acceleration is 1/6. Therefore, the weight would also be 1/6. Therefore, as acceleration due to gravity on Moon is equal to 1 by 6 into acceleration due to gravity on Earth. Therefore, weight of an object on Moon would be equal to 1 by 6 times weight of the object on Earth. So if you are weighing 100 Newton on Earth, अगर आपका weight 100 Newton है Earth में, suppose for example your weight on Earth is equal to 100 Newton. So what is your weight on Moon? Weight on Moon is equal to 100 by 6. So it is somewhere nearly equal to 16.66 Newton. 16 6 are 96. Now you can find out in another way also. Like you know the weight of your weight is 100 Newton. Or you can do weight is equal to 100 Newton. Therefore we get mg is equal to 100 Newton. So what is m? 100 by g. So it is 100 by 10. So it is 10 kg. If you are having 10 kg on the as the mass of your body, so mass is 10 kg. Therefore weight on Moon is equal to m into G Earth divided by 6. So it is 10 into 10 by 6. So it is 100 upon 6. So you will get 16.66 Newton. The same thing, you will get the same thing as the result, because the acceleration due to gravity on the Moon is 1 by 6 times that of the Earth. So this is all for today. In the next video, whenever we are meeting next week, for the next lecture, we will be talking we would be generally talking about some very interesting, some competitive based numericals on Newton's law of gravitation and acceleration due to gravity. So most of you must be interested in some typical numericals. We would be talking about a few numericals which mostly come in the competitive exams. So until then, practice these topics. These are very interesting. If you practice it once, you will understand it very clearly, and try to solve more and more numericals so that these topics becomes very interesting and easy. Thank you so much.